naming polynomials two ways, by number of terms and by degree. Now take a few minutes to copy this down. More examples of naming polynomials by the number of terms. Notice the definition of monomial. Now we'll look at naming polynomials by degree. Understand that the degree is determined by the exponents. Okay, so when we're dealing with naming polynomials by degree, we look at the exponent. X to the 0 is going to result in a 1 because any number raised to the 0 exponent is 1. Well, 1 is called a constant. Just like 4 is a constant, 5, 6, 7, whatever. I've given some examples here. 4, -8, 1. That should be 1.5, not 1 comma half. You can fix that. These are all examples. These are all examples of constants. All right, x to the first is first degree linear. Notice that these two colors are different. There's a reason I made them different. It's because I don't have to put this 1 here. That 1 is understood to be there. So understand, if you just see a variable, it has a 1 for the exponent. It is first degree or linear. X squared, second degree, quadratic. X cubed, third degree, cubic. X to the fourth, fourth degree, quartic. X to the fifth, fifth degree, quintic. And then after fifth degree, there are no special names. So if you have something that's to the 11th degree, it's just 11th degree. If you have something to the 1000th degree, you just write 1000th degree. There's not a special name. Now, I'm going to ask you to name these by the special name rather than just what number they are. So you're going to have to memorize these. And that's what I'm going to ask you for on your test, or quiz and test. The special name. Now, after you get past 5, of course, there is no special name. All right, let's continue. All right, here we have some more complicated degree problems. Here we have some more complicated degree problems, and the reason they're more complicated is because of the addition of another variable. Here we have more than one type of variable. We've got an x, we've got a y. When it comes to naming the degree of a monomial, when there are more than one variable, you simply add the exponents. Now this has nothing to do with laws of exponents that we use when we multiply, add, divide polynomials, okay? This is simply a degree addition. So this is not third degree like some people would think because the highest exponent is 3. This is fifth degree because 2 plus 3 is 5. So add the exponents within the monomial. In part B, this is fifth degree as well because notice 4 and 1. Now notice the 1 is a different color because it's not supposed to be there. It doesn't have to be shown. Anytime you have a variable, we understand that the exponent is 1. So 4 plus 1 is 5. Here we have a 5. Here we have 2 plus 2 is 4. So this is fifth degree. Now, whichever term is the highest of all of the terms in that polynomial, whichever term has the highest degree, that is the overall degree of that polynomial. So this is a fifth degree trinomial. This is a fifth degree monomial. All right? Now here are some other examples. Just quickly jot them down so that you can have this in your notes. 2x to the first, y to the first, plus 5wz plus 11y squared. This is going to be second degree. All of these terms are second degree. Therefore, the whole thing is second degree. The overall degree is second degree. We have 9b to the 6th plus 7b to the 5th plus 5b to the 4th. There's only one variable. That makes it super easy. This has got to be 6th degree because the highest degree of any of the terms is 6th degree. The last one is a 4. 4 Might as well be 4 times x to the 0. To the 0 is a constant. Anything x to the 0 is going to result in a constant. So 0 degree constant. Okay, let's take a look at the answers to these examples. Naming each polynomial by degree and number of terms. Technically, it doesn't matter what you put first, the degree or the number of terms. But generally speaking, it's better to put degree first because it's more grammatically correct. If I say quadratic trinomial, I'm describing the trinomial with an adjective, quadratic. It's a quadratic trinomial. Anyway, it sounds a little better. So number 1, Stephen. That's okay. It's fine. So what is it? What degree is it?
4.
It is 4th degree. All right. So that's going to be quartic. And it is a... All right, Jalen, number 2.
I'm guessing this is a monomial.
It is a monomial.
And constant.
Not a constant.
It's linear.
It's linear. Yep.
Linear.
Linear? Yeah, hey. Let's say that. All right, number 3, angel. Angel. In the world. Who's angel?
You got it.
I had an angel one time, though. Didn't I?
Last year.
Yeah.
Oh, I did have angel last year. That's right. All right, let's go with another A. Allison. All right, what we got?
2nd degree quadratic.
Okay, so quadratic and how many terms? You see 1. So monomial. If there's no plus or minus, it's got to be monomial. All right, Javon, number 4. Okay. Good. All right, so those are some good examples. Okay, so now, in order for us to be able to add, subtract, multiply, and divide polynomials, we've got to understand laws of exponents. Now, this is stuff that you've seen probably more than once over the years. And the way I've got this laid out is I've got the name of the property or the law. I've got the actual visual of the algebra of that law, and then an example of that law or property. So the first one is negative exponents. The negative exponents property tells us that we're going to take, any time we have a negative exponent, we're going to basically take the reciprocal of the expression while putting that exponent with its base in the denominator, basically, or the other, whether it could be numerator or denominator, but we're going to simply change the sign of the exponent. Okay, so here in our example, we've got 4 to the negative 3. And what we're going to do is simply act like we're just going to basically reciprocate this thing, but then change the sign of the exponent. So it becomes 1 over 64. Example 2, 1 over 5 to the negative 2. Notice this time, the negative exponent is in the denominator. So again, we're going to take the reciprocal and change the sign of the exponent so it becomes 5 squared, or 25. There is a restriction. Anytime you're dealing with variables in the denominator, that variable cannot be equal to 0 because you can't divide by 0. All right, let's take a look at the next property. Okay, so when we multiply powers with a common base, notice the same base here, A. We're going to add the exponents. So we look at our example. We've got x squared plus x to the 5th times x to the 5th equals x to the 2 plus 5, which is 7. When we're dividing powers with a common base, we're going to subtract the exponents. Therefore, we would have, for our example, 11 minus 3, which is 8. So x to the 8 is our solution there.
And you always do the top minus the bottom.
Correct. So when we deal with power of a power, we've got a power that's inside parentheses, and we say, you probably heard, if you took Miss Fortier last year, you probably heard her say this a lot, quantity. All right? If you hear somebody say, or a teacher say, the quantity of such and such, raised to an exponent, the quantity means the parentheses. So we would say quantity, a to the m, raised to the n. Okay? That separates and lets people know the difference between parentheses, a to the m, quantity, and then raised to the n, to just saying a to the m n. That's a little bit confusing if you don't say quantity. So here we are multiplying anytime there is an exponent outside parentheses. We're going to distribute that exponent onto each of the exponents inside parentheses. So 7 times negative 3 is negative 21. But we don't want to leave it with a negative exponent. We always simplify. So this becomes 1 over x to the 21. And then we have power of a product. We have a product inside parentheses, raised to the nth degree. So we're going to multiply the m by each of the exponents inside the parentheses. That's going to give us a to the m times b to the m. And then, same thing here. 2 gets multiplied onto each exponent inside parentheses. 2 to the 6th is 64. X to the 4th, y to the 10th. Any questions about those properties? Okay. The next next property we'll see is the power of a quotient. So here we have a quotient inside parentheses, but we're doing the same thing. We are distributing the exponent outside the parentheses onto each of the exponents inside parentheses. Okay, so here it's important to understand that anytime we have variables in the denominator, those variables cannot be equal to 0. So our b value cannot be equal to 0 in this first example, or in this first rule. In the second version of this property, neither a nor b can be 0, because what we do when we have a negative exponent with a fraction in parentheses, we're going to have to take the reciprocal of that fraction and then distribute the m. So we basically change the sign. So we reciprocate it and then change the signs. So this becomes b to the m over a to the m. But since b started in the denominator, b can't be 0. Since a ends up in the denominator, a can't be 0 either. Because you can't have 0 in the denominator of a fraction. Okay, now here's our homework assignment. But we're going to use some of it as our ticket out the door. We're going to be using tickets out the door this year as often as we can. And all that is you show me you know how to do something before you leave. So, in your book, pages 258 to 259, we're going to do these problems. Now, this looks like a lot of problems, but it's really not. I mean, 3 problems, 2 problems, 3 problems, okay? So it's not that much. Now, I've done a few of these problems for us. So before you get started, let me go ahead and show you kind of some things. If you turn to page 258, number 2 asks us the difference between 4x squared and quantity 4x squared.
Because the second one you got to look like.
Exactly. They are different. The reason they're different is because here we are squaring 4x in the second expression, which means I've got to square the 4. 4 times 4 is 16. 16x squared. So they're different. The next one, number 3, says is a negative number raised to 777th power a negative or positive number? Explain. Well, look what I did down here. I'm explaining it by showing you some other examples. If we take negative 2 raised to the first, it's negative 2, right? If we take negative 2 squared, it's negative 2 times negative 2, which is 4, which is positive. If we take negative 2 to the third, it comes out to be negative 8. Notice the pattern. Negative, positive, negative. When my exponent is odd, I had a negative. When my exponent is even, I had a positive. So since this is odd, we know that negative 2 to the 777 is going to be a negative number. Alright, then I did number 5. Now, number 5 was not one of your homework problems. I just wanted to look at it. Notice that we got 3w z to the negative 4. Now, is that negative 4 being applied to every part of that monomial? To every factor of that monomial? No. What does the negative 4 go with? What base? Just z. Now, if we had parentheses, we would have to apply it to all of the factors. But since it's only attached to the z and there's no parentheses, the only part that I'm going to move down, flip over, if you will, is the z to the 4th. So it becomes 3w over z to the 4th. And you got to keep that in mind. You got to know the difference between when there's parentheses and when there's not. All right, so what you're going to do for your ticket out the door are problems 6 through 8. We've already done 2 through 4. All right, this was number 2. This was number 3. We didn't do number 4. Okay. So you're going to do 6 through 8 for a ticket out the door. Now, you can put that in your homework, just on your paper, and I'll come around and look at it. Okay, when you finish with those 3, raise your hand, and I'll take a look.